For this video, we're going to be going over division of polynomials. So the objectives of today are to learn how to do division of polynomials using long division and using synthetic division. So let's try it out. Polynomial division is very useful. There are two methods, synthetic and long division. So let's try both of them out. Let's start with long division. So we have a quartic, which is x to the power fourth, minus 3x cubed, plus 2x squared, minus x plus 5. And we have a quadratic, which is x squared plus 2x plus 2. And we're dividing them. So in long division, what you typically do is, let's take we're dividing 85 by 5. Then we put a 1 over there. We multiply the 1 and the 5. We get a 5. We subtract the 8 and the 5. We get a 3. We bring the 5 down. We get a 35. And then we just see what to multiply by 5 to get a 35. And that's 17. So that's your quotient. So long division with polynomials is very similar. So let's see what we can do to get x to the power 4. That's x squared, because x squared times x squared is x to the power 4. And we want to cancel out the x to the power 4. So let's multiply the x squared by the x squared plus 2x plus 2. That gives us x to the power 4 plus 2x cubed plus 2x squared. And then we subtract these two terms. The x part cancels out just as we wanted to, and we get a minus 5x cubed, and the x squared also cancel out. So next we bring the minus x term down. Let's put a plus 0x squared there just as a placeholder. Next, what we want to do is we want to see what we can multiply to the x squared to get a minus 5x cubed, and that's minus 5x. So we can multiply minus 5x by the quadratic, and we get minus 5x cubed minus 10x squared minus 10x. And then when we subtract this, we get rid of the minus 5x cubed just as intended, and then we get a 10x squared plus 9x. Now we can pull the 5 down, and then we can put a plus 10 over here, because that's what we can multiply to the x squared to get a 10x squared, and we want to cancel that out. So when we do that, get 10x squared plus 20x plus 20. And then when we subtract this all out, I'm running out of space. When we subtract that out, we got minus 11x minus 15. And we can't divide further, so this is our remainder. This is our quotient. So our answer is written as x squared minus 5x plus 10 remainder minus 11x minus 15. That's your answer. Let's try synthetic division. So one important thing to know about synthetic division is that you can only use it when this is a linear term. So it can only be things like x minus 6, x minus 4, x plus 8, and it cannot be things like x squared, or x squared plus 4x plus 5, or x to the power of 900 plus 4. It can't be things like that. It has to be linear. So let's try synthetic division out. The way I like to do it is, the first step you have to do is to find out what makes this term 0, and that's 2, because 2 minus 2 is 0. So we put a box around the 2, and then we write the coefficients of the term we're dividing. So we got 3, 4, and 1. So then you can draw a line there, and then your first step is always to pull the 3 down, or pull the leading coefficient down. Your next thing is to multiply the 2 and the 3, and what you get from that is 6. Then you write the 6 down over here, and then you add the 4 and the 6. And then when you get that, you write the 10 down there. Then you multiply the 2 and the 10, and what you get is 20. And then you add the 1 and the 20, and you get 21. And we are done. So we can insert what is missing there, because we got the coefficients, and we know what is going to be over here. So that's our quotient, and this last term is our remainder. It's a very simple method. And so our final thing is 3x plus 10, remainder 21. And that's our answer. So now let's try an application of polynomial division. So the question is asking, what is the root of the cubic x cubed minus 6x squared plus 11x minus 6, given that 1 is one of the roots. So if 1 is one of the roots, then we know right off the bat that one of the factors is x minus 1, because 1 is what makes x minus 1 0. So if x minus 1 is one of the factors, then we can use long division to divide this, and then we can get a quadratic, which we know how to solve. So let's do that. X cubed minus 6x squared plus 11x minus 6 divided by x minus 1. Ooh, it doesn't look like we'll have much space, so let's try moving it up. X cubed minus 6x squared plus 11x minus 6 divided by x minus 1, and then you can write an x squared over there, because that's what will make the x cubed cancel out. So we get x cubed minus x squared. Then when we subtract, we get minus 5x squared. Then we bring the plus 11x down, and then we can multiply by minus 5x, because that will cancel out the minus 5x squared, and we get a minus 5x squared plus 5x. And then when we subtract further, we get 6x, and then we can pull down a minus 6. So we get 6x minus 6, and then when we put a plus 6 over there, because that's what is going to cancel out the 6x, we get 6x minus 6 again. And when we subtract, we get a remainder of 0. And that makes sense, because if the remainder was not 0, then this would not be one of the factors. So we have x squared minus 5x plus 6 as the quadratic we wanted to obtain. And we can factor that out. That's x minus 2 times x minus 3. So now we know the roots are 2, 3, and then the original root is 1. So those are the roots of the equation x cubed minus 6x squared plus 11x minus 6. Thank you.